Hello children. Now in today's lecture you are going to learn different chemical reactions. So already we learned some of the chemical reactions in our previous lecture. So today we are going to discuss about displacement reaction. Okay. So what is this displacement reaction? The name itself is telling the meaning of this. To observe this displacement reaction, here one activity is given. What we are doing is we are keeping iron nails dipped in copper sulfate solution. So we took a test tube, right, and that is fixed to the stand, and we kept copper sulfate solution in the tube, and we dipped 2 iron nails in the test tube, right, using a thread, right. So what is happening in this reaction that we have to observe, right. So the procedure is in depth, it is given here. So after 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of the copper sulfate. You can observe the copper sulfate solution is in a very nice blue color, right. So 20 minutes you need to observe this activity. So then you take out those nails, you observe the nails and you observe the solution also. So what you are going to observe, that you have to test now. So whenever you take these nails outside, you original nails are shown here. Original nails are like this. After removing from the solution, you can observe some layer, brown color layer is formed on that nail. That is the observation that you will do. And original copper sulfate solution is in a nice blue color. After removing the nail, the solution color is faded, light blue. So you can see this one. This is the faded solution. So what is the reaction that is going to happen here? So basically what we did here, copper sulfate solution in the equation you can observe it is in the aqueous form that we have taken in the test tube, and we kept iron nails. They are in the solid form, is it not? Now after 20 minutes, what is happening? This iron sulfate is getting formed, right? FeSO4. So FeSO4 is forming and copper is coming out in the solid form. So this reaction, in this reaction some displacement is happening, you can observe that. So what is the displacement here? Iron is combining with SO4. So SO4 is getting displaced from copper sulfate and it is getting combined to with iron to form ferrous sulfate. It is in the aqueous form, iron sulfate, and copper is getting displaced. So this type of reactions are known as displacement reactions. Okay. Now similar to the displacement reaction just now we observed, we can observe other reactions also. So zinc in the solid form, if you put zinc granules in the copper sulfate solution, then also you will observe that the displacement reaction, zinc sulfate solution will be formed and copper will come out as a solid. So even if you take lead also and copper chloride if you take, so then lead chloride is formed and copper is coming out. This two, in these cases also you can say this is a displacement reaction. So it is getting displaced, the copper is getting displaced from the copper sulfate and it is getting separated, and that copper is accumulating on the nails in the previous experiment. Now we observe what is double displacement. The name itself is conveying the meaning here, right? Two things will be displaced. For example, if you observe in this activity what we are doing. So in this activity we are taking sodium sulfate which is in the aqueous form. So in one test tube we took sodium sulfate and then we added barium chloride to this one. Take a barium chloride in another test tube and both the solutions are added like this. So we are pouring barium sulfate into sodium sulfate solution. So after some time what you will observe, so here barium sulfate precipitate you can see after some time you can find this precipitate at the down of the test tube, which is in the solid form. So this is known as barium sulfate, and sodium chloride solution you can see in the tube, which is in the aqueous form. So if you observe, barium is getting combined with sulfate, and the sodium and chlorine are getting combined. So both the things are displaced here, barium sulfate and sodium chloride. So sulfate is moving towards barium and chlorine is moving towards sodium. So this type of reactions are known as double displacement reactions. So in the previous lessons, when we were telling about the activity 1.2, there we discussed about the reaction between lead nitrate and potassium iodide. So what will happen in this this one? So this is also a best example for the double displacement reaction, right? So here if you take lead nitrate PbNO3 twice, so that will be reacting with the potassium iodide. So lead nitrate is PbNO3 taken twice, it is in the aqueous form. So and that is getting reacted with potassium iodide, right? This is also a best example for the double displacement. So if you combine these two, what happens? After some time you will observe potassium iodide. So lead iodide. So lead iodide is a yellow precipitate which is in the solid form. Bright yellow precipitate will be forming in the test tube. So and potassium nitrate remains soluble in water and stays in the solution. So potassium nitrate is formed and lead iodide are formed. So in this is also example for the double displacement reaction. Next one, oxidation and reduction. What is this oxidation and reduction process? Very simple. So here one activity is given. Heat a china dish containing about 1 gram of copper powder, and you are heating that copper powder using a burner. So we have a tripod stand here, and burner is there, and we used a wire gauge here for the heating purpose. In the china dish we kept a copper powder, and we are giving heat energy. So then what happens? So the copper is getting reacted with oxygen. When heat is supplied, it is going to form copper oxide. So what happens? A black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. So first what happens? Oxygen is added to the copper and copper oxide is formed here. So whenever oxygen gets added, then it is known as oxidation. Whenever oxygen is removed or it is displaced from that substance, it is known as reduction. So in this first equation, copper is getting oxidized here, right? This is oxidation process. And in this reaction, if copper oxide is again kept and hydrogen in the atmosphere is getting combined with copper oxide, and again copper is formed and water is generated here, and this is known as reduction. So another observation you have to do here. So copper is reduced and hydrogen is oxidized. That you have to say. In a single reaction, one element is getting oxidized and one element is getting reduced. So both things can happen in a single reaction. So both oxidation and reduction, if you are able to observe in a single reaction, then this type of reactions are known as redox reactions. So if you observe copper oxide and hydrogen getting reacted in the presence of heat energy, so hydrogen is oxidation, and copper is getting reduction. So this is known as redox reaction. Now another example, zinc oxide and carbon. So what is happening? So zinc is getting zinc oxide, it is losing its oxygen, so it is a reduction process, and carbon is getting addition of oxygen, right? So this is known as oxidation. For carbon it is oxidation, for zinc it is reduction. So it becomes a redox reaction. And in the case of this one also, right? So here MnO2 and HCl, they are getting they are having a chemical reaction. So Mn is losing its oxygen, so it is nothing but reduction for manganese. And HCl, in this hydrogen is gaining the oxygen, so it becomes H2O, so it is a oxidation. So this is also example for redox reaction, right? In the previous cases also, first example what we took a magnesium ribbon and we burned that in the dazzling flame. So in that case a white substance got formed, that is nothing but magnesium oxide, you told. So that is also oxidation process, you can tell about that one. Now we discuss about this oxidation reactions in everyday life, right? So corrosion, we all know about this processor. What is corrosion? So if you keep iron, so normal if you keep iron vessels like that, after some days you will find reddish brown powder left on that bowl or vessel or something. So this is known as rusting of iron, right? So if water content is there on the iron bowl, definitely that brown color layer you can found, that is nothing but rusting of iron. And it is not good for industrial purpose also. We will have many instruments are made of iron, so if you have to take care about this process. So what happens here, it is what is this corrosion actually? So copper is getting reacted with the oxygen present in the atmosphere. Iron or copper, they will be reacting with this oxygen present in the atmosphere, and this corrosion process will take place. So not only on the iron, you can find this corrosion process even on the silver also. So if you leave silver kundis or something, even idols you will have at our home, right? So if you won't clean it for 2 to 3 days, you will find a black coating on the silver. So this is also because of the reaction that takes place with iron and oxygen. So this corrosion is a very serious problem in the case of iron actually, right? So if we leave that item like that for a multiple number of days or years, definitely that is going to get damaged after some days. So another one, rancidity. So what is this one? So we prepare some pickles at home, right? And they are having some oil containing. Whenever these kind of foods are left like that, you will find a layered kind of thing, and even the texture also changes. When you put the pickle, it will be in a very bright red color. If you leave the pickle like that, there will be a change in the smell and odor, as well as that will be changed into blackish color. So what is happening over there? That is also because of this oxidation process only that happens. So to avoid this, what we can do is, we have to keep the food in the airtight vessels. If you keep it in the airtight vessel, these reactions won't happen and the food remains fresh. And even when packing chips kind of things, definitely you will see air is filled in those chips. Why that process is what nitrogen gas we used in the storing these chips kind of thing. So why we are doing that? For the freshness of the food that we are storing in that packet. Okay, with this we end for today's session, and in the next session we discuss about the questionnaire in the given topic. Thank you.